Now, when you come here, we sometimes, let's look at what are identifiers. What is to identify in English? What do you understand when I say identify? Do you identify, can you identify this shape? Can you identify the man who accosted you? Can you identify that girl? Can you identify this building? Can you identify this picture? What does that mean? What do you understand when I say
Find
identify?
something.
Come up
To
again?
find to try to find something.
Okay, to find something or to recognize. Or to point out. Yeah. Now, in the same case, here identifiers are used to name things. So, for instance, you can think of them like an example. So, examples of identifiers are variables. Now, here when you see here, it is used to identify the name, so it's called name. Identify age, so it's called age. Those are examples of identifiers. So it's nothing out of the world, yeah. So examples are variables. Variables are examples of identifiers. So they are used to name things such as variables, functions. We look at what functions are, classes, and methods, yeah, and methods. I'll change variables to become objects because everything is an object. We'll look at what objects are later on, not right now. Okay, so they're used to find something, recognize, or to point out. Now, we have some rules. So for now, we'll just identifiers. So for now, we'll just leave it at that. But now let's look at rules for naming identifiers. For example, variables. Now, rule number one, I'll just point them out. All variables, all identifiers must start with an underscore or an alphabet. Number two, all identifiers, no, I can say the rest of the characters can be underscore or alphanumeric. Yeah, alphabet is A to Z, lowercase or uppercase. Yeah, so let me just add it here. A to Z, A to Z. Yeah, so those ones. And then here, alphanumeric, here we have A to Z, A to Z, and 0 to 9. So it can be any of that. And then you must have an underscore. Now, the next rule is that no other characters are allowed in identifiers. Yeah. And then rule number 4. What is the rule number 4? Identifiers cannot use keywords. Keywords, or what are they also called? Okay, I'm forgetting the other name. I think it's here. Cannot use keywords or reserved words. Now, in this case, rule number 1 is clear. So if I come here, let me clear. I cannot come here and say, let's say for instance, I can say, let's say, name like that. Name equals to James. This is fine. I can come here and say, so rule number 1, it can start with an underscore and alphabet. So I can come and say name equals to James. I can come and say, let's say, school equals to, let's say, JQuat. Yeah. I can come and say, even school equals to MOU. Yeah. I think there's something like that. Then I can come here and say, fruit equals to apple. it's still fine, yeah. Or I can even say fruit equals to mango. So it's still fine, yeah, because it's either an underscore or an alphabet. All these are underscores, this is alphabet. However, if I come here and say 56, let's say 5, then let's say apples, or let me say 5 student, so we are trying to say student 5, then we say James. This will say an error because we are not supposed to start with an integer. Sorry, we are not supposed to start with a numeric. Yeah, we're only supposed to start with an underscore or an alphabet. If I come here and say something like a hyphen and then I say student, it will bring a problem. Yeah, sorry, let me just complete it so that it is clear. I say Patrick, it will bring a problem because I'm not supposed to start with this one. Yeah, so that's a problem. Is it clear on point number 1? It must start with an underscore and alphabet.
Yeah, it's clear.
Okay, great. Now let's see point number 2. Point number 2 says the rest of the characters can be underscore or alphanumeric. So if I come here and say, let's say fruit, and then I say fruit 1 equals to, let's say mango, this has no problem. But if I say one fruit equals to mango equals to apple, this has a problem because it's starting with an numeric. Numeric can always come afterwards. The first one must either be underscore or alphabet. The rest it doesn't care. So it can either be underscore or alphanumeric. So if I come here and say fruit 5 and then I say equals to guavas, it will have no problem because it works fine. I can even try to execute it like that. It says guavas because it's starting with an alphabet and the 5 and the underscore are just there among the other characters. However, if I try to do something that is not alphanumeric, so something like a hyphen is not alphanumeric, yeah, because it's only underscore and alphanumeric. A to Z caps, A to Z lowercase, 0 to 9. So if I come here and say fruit, let's say fruit, then that 5, this is not an underscore, remember, yeah, this is an hyphen. It will bring a problem. So I say fruit 5 equals to, let's say, oranges. If I do that, it brings a problem because this one is not alphanumeric. Yeah, if I put maybe a star, I'm like, let me put a star, it will bring a problem because this one is not alphanumeric. This one is a special character, so that doesn't work. Is it clear on point number 2?
I've not understood where the 5 comes after fruit and it brings an error.
This is because it's the 5 is not the problem. This hyphen is the problem because it's not allowed. We only allow underscore and alphanumeric. So this hyphen is the problem. If I remove it, it will have been fine. The star, this one is the problem, the hyphen. Here the star is the problem because you only allow the following: an underscore. You only allow an underscore. Okay, it's not. I'm writing on this side an underscore. Number 2, A to Z, lowercase, and then A to Z, uppercase, and then 0 to 9. Those are the only characters being allowed. So anything like star, or let me say that, or that, or that, or that, all of them are not allowed. Yeah, or that, or that, or that, or that, sorry, or that, or that, or that, they are not allowed in the variable name. This one, we treat this one as a variable name. When it's on the left side is when it becomes an expression, it is allowed. But this one, we treat it as a variable name as it is, which is not quite right. Am I making sense?
Yeah, it's okay.
All right. So it does. This one is part of the variable name. If it was on this other side, it will be an expression. It will be executed as it is. But here we're doing assignment, yeah. So we cannot assign it like that. So it's a problem. All right. Now the other one is no other characters are allowed in the identifiers. You've already tested that, yeah. The next one is identifiers cannot use keywords. Now we have something called keywords or reserved words. Now you can be asking me, but Michael, what are these keywords or reserved words? Now these ones are special. No. Yeah, these are special words that have. Let me not call it special words. These are words that have a special meaning. That have a special meaning in Python. Now, for example, we can have class. We have def. You don't have to understand them now. We'll meet them later on. It will be clear. Right? So we have class. We have def. We have okay. We have continue. We have break. Yeah. What else? In. We have is. We have. Why are they not coming? Exception. We have no except. We have catch. Not catch. Catch is another language. We have try. We have finally. What else? Not float. Class, def, continue, break, in, is, except, try, if, elif. We have else. What else? Not catch. We have a while. We have for value in. Yeah, we have for. What else? Looping, iteration, try, catch. Finally, if, elif, else, is, in, raise. Yeah, we have raise. If, in, catch, def, class, if, elif, continue, break. Yeah, these are examples of the. You don't have to master them. When you start writing code, they come automatically because you think of the algorithm. Anyway, these are examples of keywords. For instance, so if I come here and say class equals to, let's say 4a, it brings a problem, yeah, because this one is a reserved word. So they have a special meaning. We'll see how special they are as we move on. If I come here and say continue equals to true, it brings a problem because it is a reserved word. However, if I come and say, if I want to remedy that, perhaps I do underscore class. So if I do underscore class and then I do 4a, this has no problem because underscore class and class are two different things. You can see this one has an underscore, this one doesn't have any. So they're two different things. Or I can do underscore continue equals to false. This one will work fine. Yeah, other ones are true. We have false. Yeah. So yeah, so we have examples. If I come here and say true equals to, let's say 1, it will bring an error. Yeah. However, you come and say underscore true equals to 1, it's fine. I don't advise it. Yeah, look for another word. That's what I advise. But these are reserved words, so we'll be meeting them once in a while. So whenever you see like you do something and then it says an error, just know that it's a reserved word. You can see they are being given in purple. In your machine IDE, it might be given in a different way. Is that all right in regards to reserved words?
Yeah, it's okay.
All right, we'll be meeting them more frequent as we move on. Sorry for that. So let me just copy this for your sake. Now that we have met that, we need to look at something else, and that is a note. So note that Python is case sensitive. Now what does this mean? This means variable name is not equal. How do we put is not equal on my machine? Okay, is not the same as name or name or name, etc. So it can be very variation, so that this one and this one, they are not the same. So if I come here, let me clear. If I come here and say name equals to Michael, and then, sorry, it should be a string. If I come here and say name equals to Michael, and then I come and say name equals to James, and then I come and say name equals to Ken, and then I come and say a name equals to Mary. Now, if I do name, it will print Michael. If I do name, it will print James. If I do name, it will do Ken. If I do name, it will do Mary, because they are different variables, so they are case sensitive. So you cannot say write a variable called name and then you come and call it name on this other side. So if I come here and do something like what does not exist, let me say name like that, it is not defined. Yeah, so this is an undefined variable, so it is not known at all. So Python is case sensitive. Is it making sense? Is it clear?
Yeah, it's clear.
All right, great. So then we'll go to the next thing. Now, sometimes you want to do the printing of variables. So here we'll now come and say printing of variables, or just printing in general. Now, to do printing, we use the print function. You've already interacted with functions. You don't know what they are, but you've interacted with them. So functions, we'll look at them later on, probably next week or the other week. So you do print functions. Now, when it comes to print function, this one is used to display variables or literals. Yeah. Now we have met other functions like the int function. This one is used to convert other data types to integers. And then you have met float function. This is used to convert other data types to floating point values. You've probably met with a str function, which is used to convert other data types to strings. What else have you met? You've probably met with the bool function, which is used to convert other data types to Boolean values. Yeah, and then I'll put a disclaimer. These conversion functions apply, don't work where applicable. Yeah, so that you take note of that. Now, for instance, if I come here and say print, I can do print Michael. We have used the print function. Yeah, so we have provided Michael, which is a string literal, and it has been printed Michael. I can decide to say print 56. So we have used the print function. Now, if I want to convert, let's say a string, so let me say I have the string called 56, I can convert it to an integer like that. So I provide my string, so we are converting the string data type to an integer using the int function. So this one will come and see it's called a parameter later on, yeah, not right now. So if I come and say int, and then I provide something like 78, it does 78. Yeah, so I'm converting a string into an integer. However, I put a disclaimer, because if I come and convert Michael into an integer, it does not work, because Michael does not look like an integer. So it only applies when the value looks like an integer. If I come and say int, then I provide something like 67.8, it also does not work. Yeah, for a reason I do not know. I think it's a bad design, but it's fine. Yeah, so it does not work. Yeah, it was set up like that. So you can see if it looks like an integer, it will be converted. If it looks like an integer, it will be converted. Now we can decide to also convert like remember this is a string, this one. Yeah, it is very different from this, very different from this. If you do this, it will work. Yeah, it will do 67. You're converting from a floating into an integer. This one you're converting, this one doesn't, it looks like a float and not an integer. I said if it looks like an integer, then it can be converted into an integer. But here it does not look like an integer. This is a string that looks like a float, so it will not work. Yeah. Now, so let's come here and say if a string looks like an integer, it can be typecasted. So we call it typecasting, typecasted into an integer. So we can say typecasting is the conversion of a value or variable from one data type to another. Yeah, so it's just the official name. We call it typecasting. So if a string looks like an integer, it can be typecasted into an integer. If it looks like an alphabet or a floating point value, it cannot be typecasted into an integer. Yeah, so you'll meet that error, that invalid literal for integer. Now let's try other examples so that it is hammered in. Now if I come here, let's say I do int, let's say 67.6, it will work to 67. If I do int, then I say let's say 56, this will work fine. It looks like an integer. However, if I come here and do int, and then I do, let's say 64.7, this one does not look like an integer, it looks like a floating point, it will not work. If I come and do int, and then I say something like Henry, this will not work because it looks like an alphabet. Yeah, so this one will not work. It only works when it looks like this. Is it clear on typecasting for integers?
Yeah, it's clear.
Okay,
But
so
why the first one it converts it into 67 and the other one it brings an error?
all right. So for the first one, it's because it is converting from a floating point value into an integer. It works fine. When it is a floating point value, it doesn't bring a problem. However, if it is a string that looks like a floating point value, it does not work.
Or the apostrophe or the quotation makes it to be a string.
Yes, the quotation makes it to be a string.
Oh, it's okay.
Okay, great. Yeah, the quotation makes it into a string. Now, something will not, if I do int and then I say, let's say 56.4, it will become 56. If I become and say in 56.5, it's still 56. 56.8, still 56. 56.9 equals 56. So don't be tricked that this is rounding off. No, that's not rounding off. You can see that even if it's 0.9, it's still 56. It's not being rounded up to 57. Even if it's 4, it's not being rounded up to 50, rounded down to 56. Yeah, this is what we call truncation. So we can say when converting a floating point value into an integer, truncation occurs rather than what? Rather than rounding off. So we don't round up or round down. So we rather truncate. Now what is truncation? Truncation means cutting off. In this case, we cut off the decimal part and anything on the right. So we cut off. So truncation means cutting off. We don't round up, we don't round down, we just cut it off. So we remain with 56. Is that point clear?
Yeah, it's clear.
Okay, so please take note of that. It might come in handy. so that let's say you're building a spaceship, it doesn't crash. Yeah, so we are all safe. So I'll also copy this as an example right here. Now the other thing so this int is a function. It takes in a parameter, it takes in the value that you want to convert. Sometimes it will work, sometimes it will not. At least you now know what will work and what will not without guessing. Yeah, now the other thing is you can do float. So I will clear these. So the same way I can do float, then I convert 8. 8 will become 8.0. Yeah, if I do float and I do 56, it will become 56.0. So you can see converting from an integer to a float just adds 0.0. Converting from an integer to a float just adds 0.0. Now, if I do float and then I do something like 7, it just says 7.0. Yeah. If I do float and then I do something like 8.9, it will become 8.9. So it works fine for both of them. However, if I do float and then I come here and do something like Kamau, it won't work because it does not look like a float. If it looks like a float or an integer, it is fine. Yeah. However, if it looks like anything else, it will not work. You can also do float. Then let's try 0.0. 0.0 will work fine. Yeah, or even I do 0.18, it will work fine because actually when you do 0.1, 0.1 is actually a valid float. Yeah, so you don't have to put the 0 ahead of it. So 0.1 is a valid float. So in the same way, this one is also valid. Yeah, so you can do something like that. Is it clear on this part?
Yes, clear.
Okay, great. So maybe you can write it so that it is clear. So if it looks, if it is an integer or looks like an int, or is a string that looks like an integer or a floating point value, then it can be converted. It can be typecasted into a floating point value here. And then here I can say if it looks like if it contains alphabets or special characters, it cannot be typecasted into a floating point value. Just for explanation. If I had started with that, it would have been a little bit technical, so I prefer I show the examples, then we can come back there later. Now, with that in mind, we can also try to converting strings. So strings is straightforward. Anything can be converted into a string. So if I do string 8, it will become like that. If I do string that, it will become like that. If I do string that, it can be like that. If I do string 9 point that, it is working fine. So any data type can be converted into a string. Yeah, of course, maybe it will be invalidated later when you look at classes, but for now, this is sufficient. Is it clear?
Yeah.
Okay, so for string is really straightforward. So nothing much. Now, the last one is Boolean, and that reminds me of something. Let's say, for instance, we try to do Boolean that it is true. Now, let me explain. In Booleans, we have two values. The first one is true, and the second one is false. Now, true, any value is true. Let me say, okay, let me start with the opposite. 0 is false. So let me say that. So 0 is false. Now, how will I prove that? Is 0 equals to false? Okay, I don't know whether you've done that theory. Anyway, 0 is equivalent to false, so take note of that. So I can say here, when it comes to Boolean values, 0 represents, okay, false is represented, can also, let's say, can also be represented as 0, integer 0. Yeah, so false can be represented as that. However, true can be represented by anything else. So anything else you can think of is true. Now, if I come here, let me not clear. If I come here and say Boolean 0, it will become false because 0 is false. If I come and do Boolean 0.0, it is false. Let me not say integer 0, integer or floating point value. Okay, integer 0. Let me just say 0 so that it is generic. Yeah, so if I do 0, it's false. 0.0 is false. If I do Boolean 1, it's true. If I do Boolean 2, 3 is true. If I do Boolean 1, some very big number, it's true. So 0 is false, anything else is true. Is it making sense until there? For integers, 0 by itself is false, everything else is true. If I do Boolean, even a negative value like -1 is still true. If I do Boolean, negative a big number, it's still true. So true is represented by everything else, but false is represented by 0 only. Is it making sense?
Yeah, it's making sense.
Okay, so because true means there is something, you can think of it like that, but false means empty. Yeah, for instance, if we do Boolean like that, it's false because false just means empty, like 0 doesn't have a value, so even Boolean with that is false. However, if I do Boolean Michael, this is true because Michael means it has some characters, so it is something. If I do Boolean and then I do with an empty space, it is true because this empty space, we call it a white space. It represents something. But here there is absolutely nothing, yeah? If I had added a white space, it would have been fine, but there is nothing. That's why it is false. But here there is something. That's why it is true. If I do Boolean and then I say welcome home, this is true because it contains something, yeah, so it doesn't have an element of nothing, yeah, so everything else is true. However, when it comes to 0 or an emptiness, then that is false. We look at something called a dictionary, this one will be false. We also look at something called list, this is false. We also look at something called tuple, this is false. So anything empty is false. Don't worry about them, we'll look at them later. But anything empty is false. A 0 is false. Everything else is true. Is that okay?
Yeah, it's okay.
Okay, great. So I'm going to represent this here. And that reminds me, so when it comes to, let's say, what if Michael, we decided to convert an integer into a boolean? So we do bool. No, what if we decide to convert a boolean such as true into an integer? What will it be? It will be a 1. If we did false, it will be a 0. Yeah, so 1, 0. So those are the basic ones. But however, everything else, just remember it's also true. So just remember that. Alright, so we are done with the conversions for the moment. Yeah, we are done with conversion. Do you have any question in conversions or typecasting?
No.
Okay, great. Now we're going to look at the last thing. And that is oh, actually that was what we were supposed to look at, printing. Yeah, printing variables. So I was trying to explain integer. So do you understand these functions, what they do?
Yeah, I understand some of them.
Okay, great. Now I have to explain print briefly. Let me pick my charger. Now, when it comes to printing, printing is just used to display in what we call a standard output. In standard output. Since you're getting technical, let's just call it standard output. Standard output can be anything. It can be this console here, it can be your screen, it can be several things, yeah. So standard output, just output. Now, here in input, let's say for instance, here the reason we're executing, and when I come, let me clear. The reason I come here and I say 34 and it is displayed is because we're using an interactive shell. So Python has something called interactive shell. This allows a user to experiment quickly. So it is executed automatically. If I come and say Michael plus James, it is done automatically, Michael James. If I wanted to put a space, of course, I'll add another like that. So I'll put add a space, becomes Michael James, yeah? Something like that. I've just done string concatenation, I've done it automatically. However, as much as we enjoy experimenting right here, real programs are written in files. There's a reason why you can see a lot of red errors, because where I'm writing my notes, you're not supposed to write the notes here. We're supposed to write our code here, yeah? However, so let's create a new file, and then in it, let's write some code exactly as it is. So let's copy this, and then let's see what happens. Now right here, nothing happens because you're not in the interactive shell. So what you have to do, you have to write your code, then you save the file. Yeah, so let's save it. So I'll just do Control S. I'll call it printing.py. Yeah. Now here when I run it, so you can run from here or here. So I'll prefer this one in red. You can see there is no output. Yeah, there is nothing. Literally, there is nothing. There must be something, yeah. So to do that, because you're using the interactive shell, we have to print it literally. So I have to come here and say print, and then I come on this other side, I do that. So I have provided it inside so that when I run it now displays, oops, it says Michael James. So print is when we are not using the interactive shell. So when you write your program, you'd use print function to display in the standard output. So you can see standard input, which is just like when you type your input, we'll see that later on. Standard output is just the display, yeah. Standard error is when you see some errors here. Don't worry about that. Now, let's say for instance, we have seen an example of that. Let's start basically. If I wanted to say print, I can say print hello world. Hello world. Now, I think that's what most people start with. Now, if I run it, it now says hello world. If I want to print something else, I'll come here and say print, and then I say you are welcome. You are welcome. If I do that and run it, it comes below it. So hello world, you are welcome. Yeah. Now I can now decide to print like even an integer. Let me say 67. If I run it, it comes and shows 67. Now remember, when I run it, it starts from the top every now and then. From the top. So it doesn't like continue from number 3. Yeah, so please take note of that. Now, if I come here and say print true, when I run it, it will say true. Yeah, it will say true. If I come here and say print 67 point, like that, if I run it, it will say 67.56, sorry, 67.5645, yeah, so it does like that. However, if I just came and did like 56.7, everything else will be run from the top. However, that will not be run because we are supposed to print it for it to be displayed. Does it make sense?
Yeah.
Okay, great. Now, if that's the case, what if you want to print several things? Now, if you want to print several things, let's say I have like, I want to print all of these 5. I can do like print, then I come here and say hello world. Then I come for the second one, I say, I put a comma, so you are welcome. And then I come and say 67. And then I come and say true. And then I come 67.5645. Yeah. So when I run it, so I will remove these first 5, so I'll remove them temporarily. So when I run this code, it shows hello world, it puts a space, it shows you're welcome, it puts a space, it shows 67, it puts a space, it shows true, it puts a space, it puts 67.5645. You can see that. So if you want to print several things, you just put a comma, it will put a space automatically. Hello world, you're welcome, 67 true, 67.5645. So for instance, if I wanted, now, is it clear until there?
Yeah.
Okay. Now I'm going to take this and bring it here. Okay. My tricks are not working. I want us to wind up. Now, so we have that. Now, here in printing, sometimes you want to print a variable. So, okay, let's say for instance you wanted to print your age. I'll say print I am, then I come and say 67, then I come and say years old. So because you cannot like put them together. So remember, this is one thing, you put a comma, 67 is another thing, you put a comma. So when I run it, it shows I am 67 years old because it will add a space automatically. So I am 67, it put a space, years old. So you can do that. Or you could have said, why are we struggling a lot, Michael? So you can say print, and you say I am 67 years old, which is fine. The thing I wanted to show you is that you can put various variables to show that. Now, let me remove these. Now, what if you wanted to use a variable? So you say age equals to, let's say, 78. You can come here and replace this 67 with age. So it becomes I am 8 years old. So when you run it, it says I am 78 years old. When I change the variable from 78 to 45 and I run it, it will say I am 45 years old. So I am is printed, then a space is put, then the age is being evaluated, so it's holding 45, so it will say 45, then years old will come last, so I am 45 years old. If I wanted to say name, I'll come here and say, let's say name equals to Patrick, and then I can come and say, let's say school equals to, let's say USIU, yeah. Then I come here and say print, and then I say my name is, and then I say name. So it would say my name is Patrick. And then it says I am 8 years old. Then I come and say I school at, which school? At school. So it will say USIU. So when I run this code, it will say my name is Patrick, I'm 45 years old, I school at USIU. So we are using, you can also display variables like that. Is it clear? Is it making sense?
Yeah.
All right, so I want us to proceed in the next class from here. I'm contemplating whether to give a reading assignment since we are accelerating. We have a lot to cover. All right, I'll be sending a reading assignment tomorrow so that it can be done, and it will just be expanding on these. Please practice, try to do some little practice. We'll continue in the next class. Thank you.
So what about uh
Uh-huh.
do I use Visual Studio, or what am I supposed to use? The one you're using. Which one
No,
are you using?
just use Visual Studio. It won't have much of a difference. You want us to test with yours?
Yeah?
You
Yeah, I
want us
want
to?
to.
Okay, let's do so before we leave. So let me send this code. You can share your screen. Let's test it. Uh-huh. You can go to Visual Studio.
How do I close this?
You want to close this? Uh-huh. Just go up there, then you just close. Yeah, there will always be an X.
This one. Yeah.
Yeah.
Okay, start from new file.
Yes, new file.
Then which one?
Python.
Python.
Yes. You can now paste. All right. You can now save. Okay, give it a name, or place it where you want it to be. Then you give it a name. Okay, good. Now, you can see on the up top right, there's a play button. Top right, play, yes. Now, when you run it, it will display, my name is Patrick, I'm 45 years old, I school at SIU. So you practice right here. Yeah, so just straightforward. Is it okay?
Yeah, it's okay.
All right, great. So do some practice here and there. It might seem silly at first, but it will improve. So think of things around you. Let's say you want to print like just things like I've shown here. Then you will be improving with time.
Yeah.
All right, great. Cheers and have a nice week ahead.
Thank you. You too.
All right, shukran.
He didn't even get the chance to start. Miguel lost his balance, slipped, and belly flopped straight into the pool.